How can you implement a hidden Markov model in Python? Have you ever wondered how machines can predict sequences or recognize patterns in data? One powerful tool for this is the Hidden Markov Model. Let's break down how you can implement a hidden Markov model in Python step by step. First, it is essential to understand the basics of a hidden Markov model. This model assumes that the system being modeled is a Markov process with hidden states. It consists of states, observations, transition probabilities between states, emission probabilities of observations given states, and initial state probabilities. Next, you will want to choose a Python library for your implementation. The most common libraries for hidden Markov models are hmmlearn and PyHHMM. The hmmlearn library is widely used for discrete and Gaussian emissions and works well with the scikit-learn style. On the other hand, PyHHMM offers advanced features like Gaussian emissions with covariant structures. Once you have chosen your library, the next step is to install the required libraries. You can easily do this using pip. For instance, to install hmmlearn, you would run the command pip install hmmlearn in your terminal. You will also need to install dependencies like NumPy and Pandas for effective data handling. Now let's prepare your data. Hidden Markov models requiring numerical input, so you will need to encode any categorical data into numbers. For example, if you are working with weather data that includes categories like rain, snow, and none, you can map these to integers. If you have continuous data, you can either discretize it into states or model it with Gaussian emissions. After preparing your data, it is time to define your model parameters. You will need to specify the number of hidden states. Additionally, you should initialize or estimate the transition probability matrix, which represents the probabilities of moving from one hidden state to another. You will also define emission probabilities, which indicate the likelihood of observations given a state, and set initial state probabilities. Now you can create and train your hidden Markov model. Using the hmmlearn library, you can instantiate the model, such as Gaussian or multinomial hum. Fit the model to your observation sequences using the fit method. If you are working with unsupervised learning, the model parameters will be learned from the data using algorithms like Baum-Welch. Once your model is trained, you can use it for prediction or decoding. You can predict the most likely sequence of hidden states for new observations using the Viterbi algorithm via the predict method. If needed, you can also generate sample sequences from the model. Finally, it is helpful to visualize your results. You can plot the decoded hidden states over time to interpret the model's output. Libraries like Matplotlib or Seaborn are great for creating these visualizations. To give you a practical example, let's say you want to predict weather conditions using hmmlearn. You would start by importing the necessary libraries like NumPy, Pandas, hmmlearn, and Matplotlib. Load and preprocess your data by mapping weather conditions to numbers. Then define the hidden Markov model with a certain number of states, fit the model to your data, and predict hidden states like sunny or rainy. Finally, you can plot the predicted states over time. Implementing a hidden Markov model in Python opens up many applications, such as speech recognition, bioinformatics, financial market analysis, and sensor data interpretation. Python's ecosystem provides accessible tools to apply these models effectively for real-world data analysis and machine learning tasks.